Hello class. Today we're going to look at application problems involving polynomial equations. Your task was to try page 111. One of the things I want to mention here is that um, finding the k value is a very common application type problem. So you might want to copy this one down if you don't know how to solve one of these problems. What is the value of k if x minus 1 is a factor of x cubed minus 2kx squared plus 3x plus 1? So the first step is to remember that if something is a factor, it means that you have a remainder of 0. So you need to replace a value for, or sub in a value for x to solve for the k value. So x is going to be the 1, and the answer has to be a 0. When you look at my steps here, you'll see that my first step is to take the given equation, and wherever I see x, I put 1, and set the expression equal to 0. Then I end up with a linear equation, one variable and the rest are constants. Collect like terms and isolate the value of k by rearranging and solving for k. So you can give me k equals 5 over 2 or 2.5. Now on page 111, number 10, this question says the width of a square base storage tank is 3 meters less than its height. The tank has a capacity of 20 cubic meters. What are the dimensions of the tank? Now, what you need to understand is that there's no side dimensions given to you. You have to figure it out. This is a very good example of a thinking problem, of a task that requires thinking and polynomial equations. So setting up your equation is the toughest part of this problem. And you will see that I used, if it's a square base and you have 3 meters less than its height, we're going to let the height be x. The length is 3 less than x, and the width, because it's a square, is 3 less than x. So now we have, and yes, it is common to have a same length and width if you have a square base. I just drew this diagram to show you what it means to have a square base storage, or to work with a square base storage tank. So what I need to remember is that volume is equal to length times width times height for a prism. And the volume has been given to me of 20. So I set my volume to 20, and I use my expressions x minus 3, and x for my dimensions, LWH. The rest is just me calculating or rearranging the equation to get the equation in standard form. So you'll see me do FOIL first, and then another distributive property with the trinomial. And I end up with this expression, which is not quite standard form yet. You need to rearrange the equation one more step, where one side is equal to 0 and the rest is your cubic function. You'll see there's an x cubed minus 6x squared plus 9x minus 20. This cubic function can be factored. And that's your next step, because we're in the polynomial equations unit. We need to factor this expression. And we go through the whole process of what you did to solve for your x. So the first step, and we can number them, is to find one number that can go into the equations and make it equal to 0. So that's called your first factor. X minus 5 is your first factor because 5 can be used in the x position to get 0. So that's your first factor. Your first factor then leads you to step 2, synthetic division. Synthetic division is used using the coefficients of your polynomial function and the 5. And then you work it out. You always get a 0 remainder. And the expression x squared minus 1x plus 4 would be the quadratic you have to carry through to the next step. If you can factor that quadratic, you will find more factors. However, since it cannot be factored, we take it through the quadratic formula step to find the x values that this equals. And it turns out that because the discriminant under the square root is a negative value, it cannot be solved. This expression cannot be solved. So there's no solution with the quadratic. And so my final expression shows, this is really important, that the original quadratic or cubic function can be written as 0 equals x minus 5, which is my first factor, and then x squared minus x plus 4, which is the synthetic division trinomial, or trinomial, yes. So from here, if I'm solving for x, I set this equal to 0, I get x equal to 5. Check. I set this equal to 0, and I found no solutions because of the quadratic formula. So therefore, x must be 5. And if x is 5, then your length is 3 less than, that means your height is 5, and your length is 3 less than your height, which means 2 meters, and your width must be the same as your length because it's a square base. So therefore, the tank measures 2 meters by 2 meters by 5 meters. That's a lot of steps, and hence the reason why I would group this under the thinking category. So try again with this problem. Now the page, number 11 gives you the width expression, the length expression, and the height expression, and its volume. So this is actually a little bit easier than the last example. So when I set it up, B equals LWH, it looks like this. The order of your binomials does not matter. Just place all three of them there. And then expand. And when I say expand, it means FOIL, distributive property, until you can get standard form. Standard form is a must have in order to factor the expression. So you have to have 4x cubed minus 16x squared minus 5x minus 75 equal to 0. Once you have it in standard form, then you go through the process of factoring this cubic function. And that starts with your remainder theorem using 5 to get you your first 0, stating that x minus 5 is one of the factors. And then you're going to find out this is very similar to number 10, where after you try synthetic division, it's going to end up, and you can do a check for me or try this for yourself, it's going to end up having no more solution than the first one, no more factors. So the quadratic you get from the synthetic division will end up having no solution, just like the last example. And so that means you will have to say, therefore, x equal to 5 is the only value of x for the given equation. And the 5 can be substituted into your expression. So if the expression says 2x plus 3 for the length, then it's going to be 2 times 5 plus 3 to make 13. And there's my 13 meters. The other dimensions, length and width, will be the same. Width and height. 13 meters by 3 meters by 2 meters. That will be the dimensions of the box. And number 14, I wanted to look at number 14 from a different perspective, and that is, what if we use technology to solve? So first, you need to take your cubic function and set it equal to the given distance. So the given distance was 4,088, and then you set your distance equation to that. Solve this cubic function. So factor and solve for x. So same steps as before. You will find that t is equal to 7, t is equal to negative 10.8, which means the quadratic equation can be solved, and t is equal to 13.7. And I will tell you that this is a result of a quadratic formula step, because you cannot get decimals by factoring like that. Since there are two positive answers, then you will conclude that the plane will take either 7 hours or 13.7 hours to travel 4,088 kilometers. Did you get all of that? I hope you were on the right track or somewhat successful. Now, I want you to have a look at a way to check your work using Desmos. So if I gave you that equation, and I want you to set it equal to 4,088. So your first step looks like this. And this we solved using the factoring method and the synthetic division. However, if you type this function into Desmos, But notice how I wrote it out. I carry the 4088 over to the other side, and then I write the function y equals negative 4x cubed plus 40x squared plus 500x minus 488. If you type this into Desmos, look for the x-intercepts on your Desmos graph and dismiss any of the negative values for x-intercepts because we can't have a negative time. You will find that the answer will be there in positive form. And there you have it. Check it out. Use Desmos or technology to check your work. And lastly, if you want to get a head start on your application review questions, you can do page 140, numbers 2, 3, 6, 11, or go back to the previous day's homework and catch up. Thanks for watching.